Okay, everybody, so we are on page 71 of your workbook here. Have some guided notes going along here, so make sure you stay with me. We are entering the world of complex numbers. So let's dive into these, and you may not know what complex numbers are yet, but you will pretty soon. So there are two different quadratic equations we are going to consider here. The first one we're going to consider is the quadratic equation x squared minus 1 equals 0. The second one we're going to consider is x squared plus 1 equals 0. You can solve each of these by using square roots. Okay, now square roots, if you recall from Algebra 1, is essentially the operation that undoes squaring something. So if you think about like 4 squared being 16, well, the square root of 16 is equal to 4. Okay, so that's just kind of a little refresher as to what a square root is. When you're asked what's the square root of 16, you're really asking yourself what number times itself would give me 16. So let's look at the first one here. The first one being x squared minus 1 equals 0. So if I'm going to solve this, x squared minus 1 equals 0, there's not really enough room there for me to show what that first step was. So I'll do it over on the side here. But the first step was just to add 1 to each side. So these cancel. And that's where you get x squared equals 1. Okay? So we have x squared equals 1. Now to undo a squared, as I just got done saying, to undo a squared, I'm going to take the square root of each side. Okay? The square root of something squared, the square root and the squared are going to cancel out. So that's why we're just left with x. And on the other side, we have the square root of 1. Now, going back up to the right-hand corner, the example I threw up there before. When I said to you, what's the square root of 16? And we said, oh, it's 4. Well, remember that the square root of something, when we say the square root of something, we're talking about what number times itself would give me 16. And yes, 4 times itself would give me 16. But that's not the only number times itself that gives me 16. Negative 4 also would give me, negative 4 squared would also give me 16. So when I do the square root of 16, there are two solutions. It's both positive 4 and negative 4. So in this case, the square root of 1 is not only 1, but also negative 1. So that's where these two different solutions come into play. The two solutions for the first equation are 1 and negative 1. I did not want that to be blue. I wanted that to be yellow because it goes with the first equation. When I look at the second equation and I work that out, you know, my first step is going to have to be to subtract 1 from each side. Right? If I'm trying to get that x squared by itself, I'm going to subtract 1, and then I'm left with x squared equaling negative 1. Alright? That's what we have here. Now when I undo a squared with a square root, what I'm left with is x equaling the square root of negative 1. Now, here's where we need to be careful. Okay? Where we need to be careful here is that when I say the square root of negative 1, if you grab your calculator and you do square root negative 1, you're going to get an error message. Can't be done. Because the question we're asking is, what number times itself gives me negative 1? Well, negative 1 times itself would be negative 1 times negative 1, which is a positive 1. 1 times itself is just 1. The problem is that we cannot have, anytime you have a radical with a negative under it, it's not going to be possible. Because we cannot have a number times itself end up being negative. So the solutions to this are both positive and negative square root of negative 1. Okay? Now, which of these are real numbers? Well, 1 and negative 1, those are my real numbers. The reason that the square root of negative 1 and the negative square root of negative 1 are not real is because it's impossible. We can't do it. Okay? Over on the side here, we have the graphs. Okay, this is the graph of y equals x squared minus 1. This down here is the graph of y equals x squared plus 1. How do the graphs confirm what we just decided in the first part? Well, of all the things that we talked about when we graphed parabolas, we talked about vertex. Okay? We talked about y-intercept, which happens to be the same thing on each of these. It also happens to be that vertex. Okay? We talked about axis of symmetry. But the one other thing that we talked about were x-intercepts, and we talked about how x-intercepts are also the solutions to the equation. Notice this graph does not have any x-intercepts because your x-axis is down here. Since it does not cross the x-axis, there are no solutions. There are no real solutions because it does not cross the x-axis. Up here it crosses at x equals 1 and it crosses at x equals negative 1, and not surprisingly, those were the solutions. So for part B here, you can say anything that you would like to say to make that clear. Maybe you say, well, the graph of the x squared minus 1 function has x-intercepts at 1 and negative 1. I just realized I did those backwards. This one's negative 1 and this one's positive 1, but you got the point. The graph of x squared plus 1 does not have x-intercepts, therefore it does not have real solutions. Okay? So, where does this take us? Well, where this takes us is that before now, anytime you had the square root of a negative, you were told to just put no solution or put error, and you're just like, that's it, done, can't do it, just quit. Well, we're not going to quit anymore. Okay? When we have a graph that does not cross the x-axis, there are solutions that are considered to be imaginary solutions using this lowercase cursive I. All right? Well, what is I? Now, there's a bunch of stuff here that's, kind of written to help explain it. I want you to write down the fact that the square root of negative 1 is equal to I. Okay, we're going to start replacing the square root of negative 1 with the number I. Now, I is not a variable. We are not solving for I. It's a unit that tells us that at some point we had a negative under the radical. Okay? Now, they talk about the product property here in that, if you have two numbers being multiplied together, say I had the square root of 6 times 4 under a radical, under a single radical, I can rewrite that as the square root of 6 times the square root of 4. Okay, that's all the product property really says. The way that's going to help us is because my goal when I have a negative under a radical is to isolate the square root of negative 1, because I know I can replace the square root of negative 1 with an I. And then I can do actual work with whatever is left under the radical. For instance, The square root of negative 2, I can't do anything with it. Okay? But when I write it as the square root of negative 1 times 2, then I break it up as the square root of negative 1 times the square root of positive 2. Then I can take the square root of negative 1 and make that I. Okay? So I get rid of that negative under the radical. Look at the second little example here. The square root of negative 4 is the same thing as the square root of negative 1 times 4. Tell you what, let me just rewrite it just to stay consistent with the order they do it here. Let's call it the square root of 4 times negative 1, which I can then split up and write as the square root of 4 times the square root of negative 1. The square root of 4 I know is 2. The square root of negative 1 I now know I can write as I. Now the shortcut to this is basically to say, okay, if you have the square root of a negative, say I have the square root of negative 6. The shortcut to this is to kind of say, all right, bring that negative out in front and call it an I. So now this is just I radical 6. And then if I can reduce square root of 6, I'll reduce the square root of 6. That's kind of the shortcut in this. Alright, so let's kind of finish up this page, this discussion, by talking about complex numbers, what they are, what real numbers are, what imaginary numbers are. Now real numbers, all the stuff in this circle down here, real numbers are everything that you've dealt with before we started this unit in your math career. Okay? Square root of 3, that's still a real number. Even though you get an ugly decimal, it is still a real number. Okay? Negatives are real numbers. The only time imaginary numbers are introduced, like these over here, is when you have a negative under a radical. So the square root of negative 5 has to be an imaginary number because it is a negative under a radical. Or any of these other terms that have i's in them, those are imaginary terms. Whereas complex numbers, well, these are made up of one real component and one imaginary component. Each of these have both a real component, and maybe I should stick with the colors that I use below with these arrows. Each of these have a real component, which would be the 5, the 2, and the 12, and each of these have an imaginary component as well. That's the parts here that have the i's with them. Okay? Real parts and imaginary parts together make up a complex number. All right.